and today I'm going to be talking to you about our recently launched FGC array measurement system, which is designed to accurately measure fiber array units, also known as FAUs. So a little bit about ourselves at Arden Photonics. So we design and manufacture measurement equipment here in the UK for customers all around the world. And we believe we're one of the only specialty fiber measurement specialists. So we look at hollow core fiber, PM fiber, multi-core fiber, amongst many others. So yeah, we aim to cover many measurement challenges that our customers face, and our expertise extends to fiber geometry, refractive index profile measurements, encircled flux, and others. So today, however, I'm going to be talking about our new product designed to measure the geometry of fiber arrays. So this product builds on our experience of measuring the geometry of single fibers with our FGC range of products. So for anyone unfamiliar with fiber array units, there's the image on the top right of a typical FAU. So basically 1D or 2D arrays of fibers that are spaced often around 127 or 250 microns apart from each other. So typical FAUs can have numbers of fibers anywhere from sort of 2, 3, 4 up to maybe even 100 fibers in a row. These fibers, or these FAUs, are typically on the end of bundles or ribbons of fibers, and just often used to help couple the light from these fibers into or out of arrays of waveguides or even photonic integrated circuits. So our FGC array is capable of measuring fiber arrays for both. Wrong thing there. Where was I? Oh yeah, so we can measure these fiber arrays in both R&D and production settings. So we pinpoint core locations with accuracy up to 0.25 microns. This basically helps manufacturers and customers ensure the best coupling between components with the minimal loss of light. So the unit itself has a fairly small benchtop footprint of 450 millimeters square. We've got configurable external illumination boxes to help meet the needs of all our different customers. So as we've briefly went over, fiber arrays have numerous uses in industry. So it extends to sort of sensing, telecoms networks, data centers, photonic integrated circuits or PICs, along with the sort of medical and bioscience industries. So here we've got an image of a typical fiber array. The fibers are spaced 127 microns apart in V grooves and then epoxied in place. And the front surface is polished flat. And that's what we're looking at there, the fibers in the V grooves. And beneath that is the image of the illuminated cores. So the FGC array scans across the surface of the FAU, illuminating those cores. And it can measure FAUs up to 22 millimeters wide. So in addition to single and multi-mode fibers, we can also illuminate PM fiber stress rods and assess their angle relative to the array baseline. So that's another sort of essential measurement for customers to make sure that the PM fiber stress rods have been aligned correctly and will match up between two manufactured components. So our external illumination boxes allow for flexible core illumination at 630 nanometers. The system is designed to illuminate the cores with a consistent sort of symmetrical fill, which we've found through testing is needed for the most accurate measurements. So we have currently designed options for MTP and FC connectors, and we're looking at developing systems for bare ribbon fibers and other connector types. So the high accuracy translation stage is the key basically to achieving the core position accuracy that we need for our customers. We use a laser interferometer as part of our sort of factory calibration process, basically to characterize the translation stage in both the X and the Y axes for minimal error. Meanwhile, the optical system has been refined to ensure the best results possible. So we have a large field of view of 1100 by 800 microns, which allows for a quick and easy setup and focus. So basically, we try and ensure that all sort of fiber arrays of all different shapes and sizes are easily visible on the screen. We can then zoom into the correct region of interest and get the measurement going. So image distortion, again, as part of our calibration process, is assessed and removed, resulting in the most even and sharp images possible. When it comes to fiber handling, we've done a great deal of work to come up with a versatile and adaptable system. So we use a 32 millimeter wide adjustable array holder that's capable of managing fiber arrays that are ranging from 2.5 to 22 millimeters wide. And our system also has a tiltable mount, which allows the front end face of the FAU to be tilted by up to plus or minus 8 degrees. So we believe this sort of covers the vast majority of FAUs that we've seen, but we also have the ability to basically design custom fixtures for specific FAUs if required. So a little bit about the software. So this is a brand new software suite that we've designed for the FGC array. We developed it to allow for quick measurements using an adaptable array template system. So that's a template system that allows the user to specify things like the length of the array, the spacing, and the fiber type. But as well as being quick, we've also tried to allow the user to do deep insights into the data and results, so allowing people to really drill down into individual measurements of the fibers, see what is going right with their fiber array, but also if something's going wrong, they can get an idea of that as quickly as possible. So measurements are typically very fast. We're looking at a few seconds per core, which obviously matters greatly for when you've got arrays of up to 100 cores wide. And then plus there's additional time for the setup and the focusing at the start of each measurement. But we've got that down so that arrays of up to sort of 8 fibers complete in less than a minute. And the software has been designed to be suitable for not only R&D and laboratory use, but also for production environments where we can save full data sets for later analysis. The system can be controlled externally through APIs. So we'll be demonstrating the FGC array itself at the Laser World of Photonics in a few weeks' time in Munich, alongside our MPA 600 refractive index profiler, which we introduced on through EPIC a few years ago. Just some contact details here. If you've got some questions at a later date pertaining to the FGC array or any of our other products. And that's Rob there, who's our business development manager, who will be in contact. Okay, thank you.